Hello and welcome to today's class. Let's look at yet another concept called the square charge configuration. In the next class, we'll look at the rectangular charge configuration. Let's look at the square charge configuration. Is by definition, a square charge configuration involves the arrangement of charges at the corners of a square as shown below. Right, so each corner of the square, please, I'm assuming this man is a square, please. So each corners of this square, observe that charges are placed at each corners, as you can see. So this man is referred to as a square charge configuration. So for a square charge configuration, charges are placed at the corners of the square. All right, without wasting much of our time, so for better understanding of this concept here, for better understanding of square charge configuration, let's take an example and see how it works. By the way, I've done a video on linear charge configuration, triangular charge configuration. So the two videos are available. You can check my YouTube channel, or I'll drop the link to the two videos in the description of this video. So if I won't watch that two video, you can literally better understand this square charge configuration. So do it to watch it too before you dive into square charge configuration. Let's take a quick sample problem under this and solve together. Magnitude and direction of the resultant force on the charge Q2 be placed on a square whose corners are placed with point charges Q1 are equal to 2Q, Q2 equal to 3Q, 3Q equal to 4Q, 4Q equal to 5Q, and the distance between the charges is 5 meters. Q is equal to 2 microcoulomb. The charges are placed in clockwise direction, starting with Q3 at the bottom right hand corner. Let's solve that question. So the question says, now listen, that question is in word form. Let's tax the question there. You can hear the word square. So in the question there, figure out if it's rectangle or square. In this case here, it's a square. For a square, draw out a square this way first. So solution, draw out a square. I'll erase this Q1, Q2 concept. Draw out a square as in this case. Please don't just come in here and just jump and put Q1, Q2, Q3, No. Check your question very well. It says that, observe please, check the last part of the question. It says that the charge are placed in clockwise direction. Clockwise, starting with Q3. So I'm starting with Q3. Where it says at the bottom right hand corner. So this is my right hand, bottom. This is top, bottom right hand corner. So my Q3 will start from here. So Q3 should be here. This Q3, I'm moving in what? In a clockwise direction. So Q3, what next there after Q3 is Q4. After Q4, Q1 and what there? And Q2. This like what the person is telling me. Some person will tell you the direction. This one here is telling me how I'll start. So Q3 first, Q4, Q1, and Q2 are stated here. It says that, now listen, it says that find the magnitude and direction of the resultant force on the charge Q2. So I'm looking for the resultant force on the charge Q2. That's F2 resultant. So F2 resultant, please. I'm looking for F2 resultant. On the charge Q2, placed on a square whose corners are placed with charges Q1 to Q. So I'm giving some things, please. Parameters, please. I'm giving that Q1 is equal to Q2, Q2 equal to Q3, equal to 3Q. I'm giving that Q3 equal to small 4Q, and Q4 is equal to what? 5Q. These are what I'm given from the question here. So I'm given this stuff here, and I'm told that And the distance between the charges is 5 meters. So yes, 5 meters. Of course, what should be here? Of course, 5 meters. Why? A square has all sides equal. 5 meters, 5 meters, and then 5 meters. All right. I'm given the value of Q. So Q is a constant in this case. Q, small q, is given as 2.0 microcoulomb. So microcoulomb. So Q, this Q is given there as a constant. All right, please. I'm done with analyzing the question. Let's now solve, please. The one says find resonant force on the charge Q2. That's your Q2. That's F2 resultant. So F2 resultant. So F2 resultant is equal to F21. So F21, F23, and F24. So F21 plus F2 F21 plus F23, F22, F23, please. So F2 from here now, FQ charge here becomes Q to this, and to this. So that becomes Q1. So F21, so F21, F23 plus what? F24. So F24. All right. Let's get the value of F21. Let's get F23 and let's get F24, one after the other, and then we'll put them here and we'll get our final answer. So let's get F21 first. Let's get F2. Let's get F21. So F21 is equal to K Q1 Q2 all over R12 all squared dot unit vector of R12. Get this one first. So let's get R12. R12 is equal to R1 minus R2. R1, sorry. See, F21, that becomes Q1 all over R21, please. Then 2-1 will be here. Is 2-1 arrangement, please. 2-1. So R21, please. R21 is equal to R2 minus R1. R2 is the origin, is a starting point, origin, that's 0, minus R1 in brackets. R1 is this. I'm moving this way is negative of x. That becomes minus 5 meters I. That's all. So I'll move here to get to Q1 or R1. In this case here, my R21 will be equal to what? 5 meters I. Let's get magnitude of R21. So magnitude of R21 is equal to what? The square root of that value all squared. So 5 all squared. So the value of R21 is given as 5 meters. So magnitude of R21 is 5 meters. Let's get unit vector of R21. So unit vector of R21 is equal to position vector of R21 all over the magnitude of R21. All right. This one here is this one. That's 5 meter high, 5 meters high all over. This gives what? 5 meters. So this will cancel this. So the value of unit vector of R21 is given as I. Now put what you have inside this and get F21. Let's move to F23. So substituting Substituting, I'll have that F12, F21 is equal to K. K is of course K. Let's just write it this way. K is this. Q2. What's Q2? Q2. By the way, the Q in this question here are in capital Q, capital Q, capital Q. So I'll have to put them in capital Q, please. Capital Q2, capital Q3, Q1, right? So K, capital Q2 is what? Capital Q2 is 3Q. So I have 3Q into Q1. This Q1 is what there? 2Q. So I have 2Q all over this one. Magnitude of R12 is 5 meters. So that's for 5 all what there? All squared. This one is this. From this one here, square is square. Dot unit vector of R12. That's I. I have I here. This equal to 2 times 2. Sorry. 3 times 2 is 6. This becomes K. Please, what's K? K is constant. 9 times 10 to power 9. That's K. K into 2 times 3 is 6. Put the 6 here. Into Q times Q gives Q squared. So I have Q times Q gives you Q squared. And we know that Q times Q gives Q squared. That's Q squared. Alright, Q squared this way. And Q initially was what? 2 microcoulomb. So change it there, change it to save time. So Q times Q is Q squared. So for Q, 2 times 10 to the power minus 6. Then all squared. This value is Q. Then square it. All over 25 dot I. Let's get a value of F12. If I punch it properly, it should give me 0.0000864 in bracket I. Punch everything here. I'll have this value. This I should come here. Now multiply together. The value of F12 now, sorry, F21 now will be equal to 0.0084 Newton high. So that's my value for F21. So I've gotten the value of F21. So F21 done. Let's get F23. Please let me put F21 somewhere here. So F21 gives me 0.0084. All right. Let's get F23. 0.00864, please. 864 Newton high. 64, please. All right. I've gotten F21. Let's get F23. Let's get F23. Let's get F23. So F23 is equal to K Q2 Q3 all over R magnitude of R23 all squared dot unit vector of R23. All right. I have this place. Get this part first. So let's get R23. R23 is equal to R2 minus R3. R2 starting point, that's 0 minus in bracket R3. Please, this R2, this R3. Yeah, I'm going downwards. Downward becomes negative of Y. Negative 5 meters for Y. That becomes J. Y has X. J. Here now, the value of R23 will be given as plus, my next is plus, that's 5 meters J as my answer. Let's get the magnitude. The magnitude of R23 is equal to the square root of that term all squared. This will give me 5 meters. So the value of R23 is what? 5 meters. Let's get unit vector of R23. Unit vector of R23 is equal to the position vector of R23 all over the magnitude of R23. This one here gives me 5 meter high, so 5 meters J per se all over. This one here gives me 5 meters. This cancel this, I have J. So the value of R23 unit vector is equal to what? J. So J is the value of R23. Now at this point now, substituting. So substituting, so this F23 now F23 is equal to K, is K. What's Q2? Q2 is what? Q2 is 3Q into Q3. What's Q3? Q3 is this, and that's 4Q. So 4Q all over this one here is this, and the value is 5. That becomes 5. By the way, a square is here. Put the square here. Dot. This vector is J. So I have just J. From here, this is now equal to, we said initially 3 times 4 is 12, so I have K is 9 times 10 to the power 9 into 3 times 4 is 12 into Q times Q is Q squared, and neutrally Q itself is 2. That becomes 2 Coulomb. That's 6 all squared. The square is coming from Q times Q is Q squared. So this Q, then is square all over 25 dot J. Punch everything here and let's see what we get. Let's get F23. So F23 will be equal to, if I punch this very well, I should have about 0.01728. So if I punch this, I should have 0.01728 J. So that becomes Newton J. Punch everything here. 25. So punch everything here. I'll have this. Then force is in Newton. This J will come down. So the value of F23 is this. So F23 is given as 0.01728 Newton J. Here was Newton I. Alright, let's get the final one. I was in F23. Let's not get F24. Let's get F24. To save my time, F2, change it to 4. F24 will be here. 4 will be here. 4 will be here. That becomes R2 minus R4. 4 will be here. I just have to clean this place. Only this place. Clean this place alone. Clean this place. Clean this one. Alright. Clean this part. This R24 will be here. Replaced by 4. Alright. R24 4 should be here. R24 4 should be here. 4 should be here. This value are not yet correct. Erase this one. Alright. R24. Let's get R24. Alright. 24 should be here. So let's get R24. From here, please look up, please. Out F24 per se, that's KQ2 Q4. Those are what you have here. So R2 starting point, that's 0 minus R4. R4 is here. To get to 4, I can move this way, or this way. Anywhere I wish to move, is it correct? So I can move this way, or this way to get to Q4. So this way means negative of 5 meters high. Downwards, negative of what there? 5 meters J. 5 meters J. Moving this way is negative of X. That's minus 5 meters. Then I is for X. Downward is negative of Y. That's 5 meters. Then this is Y vertical. That's J. Value here gives you 5 meters I plus 5 meters I. Minus is plus. Minus is plus. So I have this place. Let's get the magnitude here. That's the square root of 5 squared plus 5 squared. Each of the terms squared. I have this place. This equal to, I'll have root 50 here. Root 5 squared 25. 5 squared 25. So that 25 will give you 50. So that root 50. Right? Root 50. That's root 50. And root 50 should give us about, root 50 should be equal to root 50, and that should be equal to give 7.07 meters. That's root 50. Then let's get in this vector. That position vector is this. That's 5 meters I plus 5 meters J all over this one here. That's 7.07 meters. I have to clean this part because it's complex there. To clean this off, rub it off. Alright. From here, since you have sort of this nature, having I and J together, separate them. This is now equal to, pick the first one, 5 meters I with this 7.07 meters, then plus 5 meters J all over 7.07 meters. Alright. Divide them, meter cancel meter cancel meter here. Alright. However, at this value, I know that the unit vector of R24 will give 5 over 7.0 there. 7.07 0.7072 0.7072 I plus 5 over the same thing, that's 0.7072 J in meters. So in meters, I can put meters outside this way. Meters should be outside this way if you want to. That's my value. By the way, sorry, no meters, because meter cancel meters. No meters, please. That's the value of R24, unit vector of R24. Now substituting I have that F24 resultant, that's F24, so F24 is equal to K, that's K, into Q2. Q2 is 3Q, now 3Q, into Q4. What's Q4 there? Q4 is 5Q, that's 5Q, all over this one here is this 7.07 meters Perhaps I can ignore the meters. All what there, all squared as refers to this dot unit vector of 24 vector. That's this value. So in brackets 0.7072 plus 0.7072J. These are the value here. All right, let's get F24. Let's get F24. From there, F24 will be equal to what's K? It's easy as 9 times 10 to the power 9 all over, 3 times 5 is 15. So I'll put a 15 here. Into Q times Q is Q squared. And Q is 2 times 10 to the power 6 minus 6 all squared. All over 7.07 squared. That's 7.07 all squared. In the bracket, I have 0.7072I plus 0.7072J. All right, I have this one. All right, I have this, please. Next task, F24 will be equal to, punch all these values here. If I punch correctly, I should have about 0.0108. 0.0108. Everything is this into 0.7072I plus 0.7072J. What comes to mind, I will expand. So this one here times this. So F24 is now equal to this one here times this. I will have 0.00764. 64 plus this times this we give 0.00764 again. 0.00764 J. I have J here. By the way, I can attach Newton to the last part, Newton, because it's force and it should be in Newton. So I have I and J in this case. Here was just F23 was just J. F21 was just I alone. So let's get the value of F2 resultant. Let's get F2 resultant. So I'll take this man off. Let me keep this one pending because we need the answer. So I'll not erase this. So let's get F2 resultant. Let's get F2 resultant. All right. F2 resultant is equal to F21. That's F2. That's 0.00864 Newton I plus F23. That's 0.01728 Newton J plus F24 is this. That's 0.00764 I plus 0.00764J. I have this place. I have this place. This is now equal to this is I, this I. You can combine this J, they can combine. So it becomes 0.00864 Newton I. Bring this I here plus this one 0.00764 I. So I together. Take J and J together. That's plus 0.01728J plus this one here 0.00764J. Let's get the final answer for F2 resultant. This is now equal to this plus this 0.1628 0.01628 Newton I. This with this gives this plus, combine these together, I'll have about 0.02492 Newton J. Alright, Newton J. That's your answer to this place. So I've gotten the answer. So the question says literally, the question says find the, let me check again please. Hold on please. It says find the magnitude and direction of the resultant force. So the magnitude of the resultant force at charge Q2. So magnitude is the magnitude of the resultant force. So let's find the magnitude of this place. So F2R magnitude is equal to the square root of each of the term. That's 0.01628 all squared plus 0.02492 squared. We have to find the magnitude of this one there. This is the magnitude here. This should be equal to the point correctly. We should have about 0.0297 Newton as the magnitude of the resultant force at charge Q2. This is the magnitude here, right? That's the concept. This is how I solve this particular problem under square charge configuration. Next class, we'll look at the concept of rectangular charge configuration.